Welcome to the next video. In this video, we'll be touching upon the number of techniques that we can use to improve the database performance. Although there are a number of techniques by which database performance can be improved, but we'll be touching upon only few of the majorly used techniques like indexing, table partitioning, and lastly the sharding. So without wasting any further time, let's get started. The first technique that we can use to improve our database performance, I think this is one of the most basic technique that every developer is usually follows as the first step. So as part of this, the indexing, what we usually do, if we have a database, right, and for our example purpose, let's consider that it's a relational database. Okay, now as a developer, what would you think? You will think that let's start to create an index on a table. If your table have, let's say, 1 million records, you will create an index out of it, and obviously on a particular column on which you wanted to search. In default cases, that column would be your primary keys, right? So in that case, your primary key will be indexed, and your index will contain that primary key and the address location. So whenever you wanted to search that primary key, you will refer to the index and get the address out of it and goes to that location directly. So that way, obviously, indexing improved your performance. You don't need to search each and every row to get that primary key value. But in that case, now you have to maintain a separate index table or index data, right? And when your table started to grow by a huge amount, let's say after a certain period of time that 1 million becomes 10 million, then that index will also grow. So it's a kind of direct proportionality between the indexing and the table. And obviously, if you insert anything in between, if you are doing some kind of deletes in between, then again this indexes which were created need to be also shuffled up. So it's a kind of overhead where you have to maintain the indexes also apart from the table, although it's improving the performance, but it also has its cons. So let's now discuss about the better technique, what you can do apart from indexing. What is table partitioning? Let's suppose you have a table which have millions of records. Now it is possible that you can split that table on a certain criteria into multiple small tables, I would say. So in that case, instead of searching your data into a single big table, you can divert your queries to multiple small partition tables. Okay, so let's consider an example here. Suppose I have a table which contains the name of the employee and their corresponding data, right? So this is employee table, I would say. So this employee table contain data for number of employees, let's say Amar, and another name could be, it's very difficult to remember all those names, so let's consider another name as Karan and some other names too, right? So there are a number of obviously the names are here, and I'm not considering all those names here. Okay, so just forgive me for that. So suppose we have number of employees there, right? And it's a very big table and it contains around 1 million of records. Now if you wanted to search something into this table, you have to obviously, with our previous technique, you have to maintain index over this table, which will also contain a number of records corresponding to these original records, right? So just to solve this problem, okay, what we can do, we can split this employee table into number of small tables. Okay, so let's say our employee one I'm just giving as a some random name to these tables, but you can give as per your requirement. Okay, so this particular partition table will have the data from, let's suppose, from A to D only, right? And this particular E to maybe M, and this particular from N to Z. What I mean with this, that employees with name starting with A to D will be the data of those employees will be residing into this partition table, and after that E to M will be residing into these, and N to Z will be residing into this table. So now if you wanted to create index on it, now those indexes will also be very small compared to what we are maintaining here, right? It might be containing number of records, but now this particular index I1 will be having a very minimum records corresponding to this table. Similarly I2, and similarly I3. Now if you obviously if you are having such kind of thing, you have to have a logic also around it, so that you can divert your query to the right or correct partition. All right, so in that case you have to maintain a kind of orchestration or a kind of logic before that, right? So let's say if you are firing any query, SQL query, it will go to that logic. It will first identify the starting name, starting letter of the your employee name, and then we'll go to the correct database, obviously via index to the correct database, right? So in that case your queries will be quite more faster, because you are using indexes, and also the overhead that you had when you were creating an index on a single huge table will also be minimized in this case. But still this particular technique also has some issues. Let's suppose this particular query that I am firing, sending to this database, have many users. If users are in very less number, let's say 100 or 100,000, that's okay. I believe my database can take that kind of load. But suppose if that load is increased to 10 million users are firing some kind of queries to this database cluster, then obviously my database will not be able to handle those queries, right? So mitigate that thing. Let's jump to the next technique. So it's about sharding. Sharding is a kind of similar concept that we discussed in table partitioning. The difference is, in case of table partitioning, we were keeping all those small tables onto a single server, onto a single database server. Now the problem was with table partitioning that if your user base or the users that are using your database grows to some extent, some higher extent I would say, then that server might not be capable enough to take that load. So in that case that will certainly hit your database performance. In sharding we have very small difference, that instead of keeping all those small tables onto a single server, we will be keeping all those small tables on different servers. Now in that case, in that way we can certainly improve the database performance, because now instead of handling those number of users by a single server, we can leverage the capability of horizontal scaling of database, and can divert those users to different servers instead. So this way obviously the database performance will be improved. So let's consider that picture again. So these are the servers. Let's say the employee 1 that I was talking earlier is residing on a server 1, right? Similarly, employee 2, which was again a partition of bigger employee table, will be residing on a different server 2, and similarly employee 3 will be residing on server 3. Now similarly, as with table partitioning, we should have a kind of logic around it so that it can divert the queries, the user queries or the users to the correct server. So this will be in some of the database, I would say this logic comes out of the box, but in some of the database cases you have to build that logic, that how you can send your request to which server, that will be written by the developer itself. Okay, so this way obviously we have the capability of horizontal scaling. So let's say this particular server earlier was having a capacity of taking that single server earlier was having the capability to handle 1 million users, right? Now that single server can take that much capacity because you are now horizontally scaling your database server. Now in combined, your total database cluster can handle 3 million users, right? And similarly, if you have a 10 million user database, then you can obviously scale it to 10 servers and you can improve your database performance. So I hope you like that video. Thanks for watching it. See you next video.